Okay.
So start.
Thank you. Well, I guess on that point, I'm thankful that Judy continued school. Because I am one of her mediocre students and I'm still up here, so I'm doing okay. All right, so just for time's sake, we'll just sort of go through this a bit quickly. So my presentation is interacting the functions using mainly interactive whiteboards. So the reason I chose this one was because I thought the generic understanding or explanation given to students about inputs and outputs and this random machine is a bit boring. So, yeah, so I've just watched the previous year's presentations. Apparently there's like a Simpsons theme, so we'll fly with that. Okay, so I thought since there are interactive whiteboards in many schools, and it doesn't really get used other than for a projector's sake, I thought let's make most of this. Okay, so just some simple ideas for analogies. Okay, so you could extend the understanding of the machine as a vending machine. So you can press, let's say A1, you get a packet of Doritos, and B2, you get a Coke or something. So you can also have toasters, so you put in bread and you get toast, so that's another way. And apparently there's these Volkswagen toasters. I'm not sure if that has anything to do with the emission scandal, but I'm not sure. And lastly, you have ATMs. So I think ATM is a good one because you press $20 in the machine and you get $20 out. Unless you're one of those lucky people that, should be going forward. Unless you're one of those lucky people that just gets free cash. Okay, but you could extend that analogy to say, something's wrong with the machine. Okay, so what my idea is using the program that comes with Interactive Whiteboard, and I think it's called Notebook, and basically I've formed this sort of activity where the cylinder is the rule now. This is the machine, and you get students to come up and you actually get them to say, what happens when you push the 1 into the machine? So you tell them to push the 1, and you get a 1. Okay, so we're trying to figure out the rule. Okay, year 11. We push the 2, we get a 4. Push in the 3, you get a 9, and push in the 4, you get a 16. So obviously this is more like, if it was real life, I actually could slide this across, you would understand. So what's the rule of year 11? What's happening? Squared, right? Yes. Good to know. Some of you know. Okay, so then you can introduce, so we're also going to go with the terrible puns of functions. Okay, we're going to keep that with Stuart's example. So now we introduce. Glad you like it. So now we're just introducing the actual function. So when x is 1, y is going to be equal to 1. Likewise for 5 and also 1,000. So then you actually put it into context. Okay, so what is this used for? Function notation. So what happens? You explain the function, what's happening. So we're putting in the 1 into the machine, and we're getting a 7. Okay, put in -1, so 2 times -1 is -2, plus 5 is 3. And lastly, for the last one there. Okay, so just to wrap up, you can also do, this also works with composite functions. Okay, so say you have a function with a function and you want to evaluate that. So you do what's inside first. Okay, so in this case, we've got a function of x squared, and we're going to put in g equals 1. So we slide that across, and we get g of x equals to 1. And now we want to evaluate the entire function. So you just keep sliding across, and you get f of x equals to 2. Now, this idea doesn't look as good because I'm just doing it in front of you, and no one is here actually pushing across. But the idea is super simple, right? It's just about layering different texts and different colors. And if I'm colorblind and I can do this, you can all do this. So if you didn't get anything from my presentation, I hope your next ATM endows you with some free cash. Thank you.